Okay, so last time we stopped when we proved that company 1 is more than company 2. Now the first thing that I want to talk about is they could ask you for p-value for the t-test of 1.4008. Again, p-value, whether it's t or chi, we need to do the DTT. Degrees of freedom, test, t. Degree of freedom, remember, n1 plus n2 minus 2, 8 plus 8 minus 2, 14. The test value is 1.4008, and we were doing this problem as one tail, upper tail, since the question was asking for more. You go to your t table, you go to the degree freedom 14. And the degree freedom 14, where do you see 1.4? It's between 1.3 and 1.7 according to my table. So it's between these two values. I go up, then my p-value somewhere between 10% and 5%. And if it happens to be two-tail, you would double these two percentages. So you get the percentages you're between first, and then you double it because it's a two-tail system. Okay, so that's how you find the p-value. They could also ask you to do the same problem, confidence interval, and prove that company 1 is more than company 2. So they could ask 90% confidence interval for difference between mean scores of the two companies. Since we know that this question is a two-sample independent, because you have two separate groups, the confidence interval formula would be average group 1, average group 2, plus minus, all confidence interval have the plus minus. T star, SP, and 1 over N1, 1 over N2. To get the T star, we need to have degree of freedom. We know N1 plus N2 minus 2, we know it's 14. I'm going to change this to 80% confidence interval. It doesn't matter, it's whatever they give you. So the degree freedom is 14, and alpha is whatever the remainder is, but we divide by 2. All confidence intervals two tails. So you all the time when you, whatever the remaining percentage is from the confidence interval, you divide it by 2. So your alpha is 10%. You go to your T table, degree freedom 14 with 10%. It's the 1345, the same number we got from the previous one. Your SP is 27,305, 1 over first sample, 1 over second sample. And the average of the first one is 35. The average of the second company is 34. So we do the point estimate. We do the difference between the two groups. So 53.5 minus 34,375. This number is 19,125. You do all of that, 1,345, 27,305, square root 1 over 8, 1 over 8. This number is 18,3626. I'll delete some of the stuff we have here. So you add them, so your mu1 minus mu2, you add the 2, you minus the 2. You minus first, takes you down to 7624. You add them, takes you up to 374876. And then if you ask, of course you have to interpret the answer. We're 90% confident, or the same stuff. Now, does this show that company 1 is better than company 2? Okay. When you do confidence interval for difference, whether it's independent, dependent, or even proportion, difference between two, basically. You could end up with two negative numbers. First one is negative, second one negative, or two positive numbers like we have here, or negative positive. If you have two negative numbers, then they must be different, since 0 is not within confidence interval. Negative, negative, you don't go through the 0, so they must be different. And since both numbers are negative, that means that group 2 is higher. When you have difference negative, the second number is higher. Here, they also different, since, again, same reason, 0 not within confidence interval. So anytime you have two positive numbers, you don't go through the 0, so they must be different. But since both numbers are positive, that means group 1 is higher. So since they're positive, that means group 1 is higher. Negative, positive, then we say they're not different, since 0 is within. And in this case, we don't know which one is more, which one is less. So you go back to the question, they're both positive, so you're in this case, and that's what you say. They must be different, since 0 is not within, and since both numbers positive, group 1 is higher, then yes, company 1 is higher than company 2. So hypothesis and confidence interval give you the same conclusion. Good. We go back to the midterm. State the hypothesis, pair, and test that you would use to test the assumption of equal variances. So just put the hypothesis and what the test is. For equal variances. Now the hypothesis, and she usually asks this way, she's not going to ask you to do the entire answer. So H0, HA. H0 you say sigma squared, sigma 2 squared equals 1, or squared not equal 1. This is what we do for equal variances. And here we say variances are equal. And here we say not equal. So for the part where you have to state the hypothesis, that's the only thing you need to say. For the actual test, it's S1, it's F test, and it's S1 squared over S2 squared. And you've got to make sure that the S1 is the higher standard deviation. Or else leave it as it is, S1 squared over S2 squared. This is the formula we use for equal variances, or testing for equal variance. So if she asked, she would ask for state the hypothesis in symbols and words, and what the formula is. And again, not equal, HA means you have a two-tailed system, but you won't be asked to actually do the complete question, so it would be something like that. Okay, so we go to the next one. Question 4. The manager of credit department for an oil company would like to determine whether the average monthly balance exceeds 80. And they did this study based on 100 accounts. And they give you the results. Question is, at 5% level of significance, so alpha 5%, should the auditor conclude that there is evidence that the average balance exceeds 80? So you start question 4, H0, HA. You always do HA first, consistent with the question. You're trying to see if the mean exceeds $80, and this doesn't exceed, the opposite. So in English, true mean balance does not exceed $80, and this one does exceed $80. Test. Obviously here we have one sample, and in the question there was no mention of what the standard deviation is. So one mean, sigma unknown. When you have one average and sigma unknown, we use x bar minus mu s over square root of n. So we got to this. Now the next question is, what's your decision rule? Again, since we're more, we know it's a one-tailed system. So for a one-tailed system, T. F T test more t-test, more we're going to reject H0. And we said it in the previous question, more means one tail, upper tail. Now to get this number, we need degrees of freedom. They tell you 100, so it's one group, so 100 minus 199. And they want you to do it using 5%. So alpha is 5%, and again, we don't divide it by 2, since it's a one-tail system. You go to the table. Now, most tables won't have the degree freedom 99. Mine has the closest to the degree freedom 99, 90. It's about 1662. Yours could be a little bit different, just a little bit different, but it's about 1662 or 166, or 1661, around that area. Now, after this, we actually do the calculations. Now, according to the formula, we need the average. Well, we know average would be the sum over n. They give you the sum, it's 8,340 over a sample of 100, so that would be $83.40. We need mu, top right in the formula. Anytime you do the top right, you go back to the hypothesis, and that will tell you what the number is. It's 80 in this case. N is 100, so the only thing left is to figure out what the standard deviation is. The 3 steps: total variations, so we need the sum of x squared. They give it to you. It's 750, 928, 9275. The sum of x is 8340. You square this and you divide by 100. So you take the calculator, 750, 928, 9275, 8340 squared over 100. And that gives you 55,372,9275. That's your SSX, total variations. We use it to find variance, which is this over n minus 1. So the 55,372,9275 over 100 minus 1, or over 99. This gives you 5593225. And finally, the standard deviation is the square root of variance. Square root of 5593225. You square root the number, and that gives you 2365. That's your standard deviation, 2365. Once you have the standard deviation, once you have the standard deviation, you're ready to put everything in the formula. So I'll do it here. So we're ready to put everything in this formula for the t-test. Average of group 1, or average, the average we found is 83.40. Mu is 80. S, 2365 over square root of 100. So we do the math. This gives you 1.4376. This is the number you get when you calculate your t, about 1.437 or 376. Now we are ready to make a conclusion. Conclusion. T-test of 14376. Is it more than this? It's not more than 1662. So for the first time today, condition is not satisfied. We do not reject H0. And in this case, type 2 could be committed. With risk equals beta. And you don't need to calculate it. So anytime you reject H0, you say type 1 could be committed and risk equals alpha given in the question. And when you don't reject, you say type 2 error could be committed with risk equals beta. Now, if you don't reject H0, you don't reject it, that means that you're not rejecting it, you're accepting it. So we don't have enough evidence to show that exceeds. So we do not have enough evidence or significant evidence to show that mean balance exceeds $80. There is no evidence of this. There is no evidence that it exceeds $80. They ask you what type of error could be committed in a separate part. We said type 2. Even if they don't say it, you always have to do it. And also find p-value. So we'll find the p-value as well. P-value, when you do it chi or t, it's always the DTT, degrees of freedom, test, tail. We determine degree of freedom n minus 1, 100 minus 199. The test number we found is about 1376, and it's a more question, so it's a one-tail system. You go to the degree freedom 99. I don't have 99, so I'll use degree freedom 90. And this line, where do you see 1, 4? It's between the 1, 2 and the 1, 6. Go up your p-value somewhere between 10% and 5%. And if it happens to be a two-tail system, you would double this. They're not asking you to explain what the p-value is, but I'll say it anyways. If they say interpret the meaning of the p-value, you say this. Assuming H0 is true, the probability of having a sample as extreme as the test is whatever the value is, between 5% and 10%. So you always say this, and at the end just say what the p-value is. And it's better, instead of H0, say what H0 is. So assuming that the true mean balance does not exceed 80 is true, the probability. So say what this is in words, rather than just to say H0. Okay. So we know that it doesn't exceed 80. From doing the hypothesis, we know that it doesn't exceed 80. The balance does not exceed $80. Now, I want to do the same question as a confidence interval and see if we can prove the same thing. So again, the alpha given is 5%. So let's say they ask 90% confidence interval for mean balance. And whether the confidence interval also shows that it doesn't exceed 80. Confidence interval for one group or one mean when sigma unknown, again, sigma unknown, they didn't mention anything about standard deviation of all. We use this formula. T star, you need degrees of freedom. We know n minus 1, and we know that it's 99. We need alpha. If it's 90%, then it's 10%. And for confidence interval, we always divide by 2. Because all confidence interval 2 10. We calculated the average, and it was 83.4. Plus or minus. To get the T star, 99, I'm going to use 90 since I don't have 99. And the 5%, I'm going to use 1662. So again, 1662. Standard deviation, we also calculated the standard deviation earlier, and it was 2365 and over square root of 100. So you bring the first number down, and you do what comes after the plus minus. 1662, 2365 over the square root, and that gives you 3.836. So now you know that mu is between, you minus them, you add them. So 83.4 minus 3.836, that takes you down to 79. And if you add them, it takes you up to 87. And of course, you need to say after this what your conclusion, or what this is in English. Anytime you do confidence interval, you need to interpret what it means in English. And 95% of all that based on the sample, you know what to write. We've done it so many times. Now, does this show that it doesn't exceed, like, can you prove from this that it actually exceeds 80? Well, it could be less. So I can't be, we're not comfortable saying that it's always going to be then more than 80 because it could be less. But if this number happens to be 81.2, say, and this is 87, then yeah, it's definitely going to exceed 80. So here you say, confidence interval shows that mean balance does not always exceed $80, since it could be as low as, and whatever the number is, 79,564. So it doesn't necessarily exceed because it can be as low as 79,564. Now this is the question. We look at the next one. Okay. Question 5 in this midterm. 2 placement exams are available that students can take to determine which math class they should begin with in their first year. It's believed that there is no difference in the mean scores that would be received for the 2 tests. So to test that using 0.05 significant level, a random selected group of students took both tests and had their score recorded. So you have one group of students, and there are 7, so one group of 7 students. And the same group, we recorded what they did in test 1 and what they did in test 2. And the numbers are 23, 20, 22, 27, 30, 35, and 27. For test 2 here, 20, 22, 19, 28, 26, 31, and 25. Now, this is a question of 2 sample dependent, also called paired sample. Why? Because if you remember the previous question, it was 2 separate groups. One doing for the test from company 1 and the other doing it from company 2. Here, they specify directly that it's only one group of 7 students doing both. So the first student did this, and that's the score for this student on both. This student did both. So you have one sample, but 2 tests. That's a dependent system. And then the question, using 5%, of course, is there any evidence of difference? So we know that it's a two-sample dependent. I'm going to stop this video now. When we come and do the last part, we will actually do the calculation. There are a lot of calculations involved. So we'll do that, and then we'll complete the question to the end.